Hi, everyone. My name is Nishant Tomar, and I'm the chairman and CEO at DigsFact. Today, we're going to show you a demo of our fraud prevention product called the PreCogs, which uses a combination of agentic AI and a generative adversarial network, GAN, to detect fraudulent transactions in under 1 millisecond, regardless of the transaction types. So it can handle ACH, wire, cards, and even real-time payments such as account-to-account, wallet transfers, Zelle, you name it, as well as cross-border transactions. In this particular demo, we are showing you debit card transaction as it will be apparent when you notice our column headers over here. And for the purpose of this demo, we have uploaded 200 transactions through this CSV file. So we're going to go through the performance of over those 200 transactions. As you can see, the average time per transaction was 1.5 millisecond per transaction. This is in our demo environment. In production, we are experiencing under 1 millisecond per transaction. So on the left side, for these 200 transactions, you can see what our performance snapshot was. 150 of them were predicted normal and were actually normal. 48 were predicted fraud and were actually fraud. 2 of them were predicted normal, but they were actually fraud. So this is our missed detection. And then none of them were predicted fraud that were actually normal. So no false positives, again, for this set of transactions. We have run a bigger data set before the demo and prepared that as well, just to show you what that looks like over larger sets of data. We ran 1.8 million transactions, and basically it shows under 2% false positives and missed detections, again, for that 1.8 million transactions. Our average false positives is around 5%. Our average missed detection is also single digit, somewhere between around 8%. So now let's jump into the transaction. I'm going to go through a couple of these just to give you an idea of what's happening here. Anything that's marked in orange is considered as a risky feature by our model, and anything that is marked in blue is considered a normal feature. And then anything that is not marked in blue or orange is irrelevant for that particular transaction. And then on the far right, we have our prediction: green for normal, red for fraud. And then you can see a column over here that shows what was the actual result. So that's what we're using to compare our missed detection and false positives. All right. Now, when we talk about these orange, risky features and normal features, this is basically specific, I should say, to each transaction. So as me, when I run when I, as a customer, initiate a transaction, what this is doing is it's comparing my behavior, the behavior of this particular account, and comparing it to this transaction to see if there is any anomaly. So some factors may be risky for one user, but they may not be risky for another user or another transaction. And what it also does is it looks at collective risk level by combining all of these risky features to make a prediction of if the transaction as a whole is fraudulent or not. So you will see this one has a bunch of orange features, and based on the combined risk level for all the risky features for this transaction, this was marked as fraud. However, the second transaction, there were risky features here as well, but they were not significant enough for the model to mark this particular transaction as fraudulent. Real quick, if I go down, this we have added just as an illustration. We can also produce different kind of reports. This is just a sample report showing you if somebody was interested in seeing the merchant category and how many fraudulent transactions they're experiencing over time. We can create reports like this, but there can be so many other types of reports. Totally depends on what you want to see. Along with that, for every fraudulent transaction, in addition to passing, whether it's fraud or not, we also provide an explanation that basically kind of at transaction level explains what factors played a role, and why was that transaction marked as fraudulent. That will help you with your regulatory audit and documentations. And before we end this demo, just quickly, we wanted to show you, but with every customer, we typically ask them to run their historical transactions through our model, and that's what allows the model to reach its optimal state. The good news is we do not need a whole lot of model the way we have designed it, regardless of the size that your company size. Um, we need anywhere between 3 million to 10 million transactions. So uh, in this bar chart, the purpose of showing this is to show you our average F score, which is a calculation of missed detection and false positives, basically reaches the optimal state in the first couple of million transactions itself. And then after that, it has reached the state where it can act or perform at its peak level. So with that, I'm going to conclude this demo. I'm happy to dig deeper into any of these, what I've shown here with you on the call. So please feel free to reach out to us, and we'll be happy to discuss in more detail. Thank you so much.